The panic did not begin from the fear of a catastrophic event, but rather from the sheer impossibility of the situation. Black holes have long been considered the final tombs of matter and information. According to the laws of physics as we currently understand them, those that cross the event horizon are lost forever. This is a cornerstone of classical theory. Once something falls into a black hole, it cannot return, cannot communicate, cannot be retrieved. Yet, against all accepted models of physics, a signal appeared. It had structure, it potentially carried encoded data, and it seemed to originate from a place where no information should be able to escape. This wasn't just a crack in our understanding of general relativity, it was a wound slicing through decades of quantum theory. Scientists began to whisper once more about the infamous black hole information paradox, but this time the discussions carried a new urgency and a creeping sense of dread that hadn't been felt since the earliest theoretical arguments. If information could, under still unknown conditions, emerge from a black hole, then either our conception of event horizons was deeply flawed, or a mechanism existed, possibly quantum in nature, that preserved and released data. The implications of such a finding would be enormous. It would mean black holes were not final endpoints where data is destroyed, but something else entirely. They might be thresholds between dimensions, or worse, communication nodes for an intelligence we do not understand. The Voyager anomaly could no longer be treated as an observational curiosity. It was now a direct challenge to the very foundation of cosmology and particle physics. Physicists attempted to frame the data within various theories: string theory, loop quantum gravity, holographic principles, but nothing fit easily. Some speculated that this was evidence supporting the holographic universe hypothesis, that information is not lost in a black hole, but rather encoded on the event horizon and possibly released under specific circumstances. Others suggested an even more radical idea, that black holes might be bridges to other universes or dimensions, and that what Voyager detected was a leak or signal from a reality beyond our own. Even as these questions tore through the scientific world, the signal continued. Its pulses were marked by micro fluctuations inconsistent with any known natural source of radiation. Further analysis revealed modulation too deliberate and too complex to be mere background noise. It suggested the presence of information, possibly a language or code. Research teams across the globe worked tirelessly to decode the signal. It wasn't binary, nor did it conform to any known computational model. Some theorized it might be based on qubits or the states of entangled particles, quantum information only interpretable through a multidimensional framework. Voyager 1, humanity's most distant spacecraft, had long outlived its expected operational life. Originally launched for a brief mission to explore Jupiter and Saturn, it had since traveled deep into interstellar space. But despite decades of surprises, nothing in Voyager's journey had prepared scientists for what it recently encountered. Beyond the heliopause, the boundary where the solar wind ends and interstellar space begins, in the cold and distant dark, Voyager recorded something utterly unexpected. Not a typical signal or cosmic noise, but an anomaly. A structured anomaly, one that seemed to originate from near a black hole. What made the event so extraordinary was not simply the anomaly itself, but what it implied. This was not a common radiation burst, nor a gravitational wave signature. It was something entirely different, something that should not be there. As Voyager drifted further into the void, its instruments began detecting a series of electromagnetic pulses. These bursts came with regular timing, their rhythm and amplitude eerily consistent, too regular to be random. At first, scientists dismissed the findings. Voyager is old. Its instruments date back to the 1970s, and interference from cosmic rays is not unusual. But that explanation didn't hold for long. What followed ruled out instrument malfunction. Multiple sensors on the craft recorded the same signal. The data was cross-checked, and the pattern held through repeated intervals. Teams of engineers and astrophysicists pored over the transmissions, and the results pointed toward a source in deep space. That source corresponded with a known stellar mass black hole located near the outskirts of the Sagittarius R, about 3,000 light-years from Earth. This raised immediate red flags. A black hole should not emit structured information. By nature, it devours everything including light. Although emissions can occur in surrounding accretion disks or via relativistic jets, those forms of radiation are chaotic, not pulsed or encoded. Not like this dot. How could Voyager have intercepted a signal emerging from a region beyond the event horizon? Initial theories explored possibilities, like gravitational lensing or a new kind of astrophysical object entirely. But as more data came, in and background interference was filtered out. The evidence became undeniable. The anomaly originated from within the black hole sphere of influence, possibly just outside the event horizon, or even more disturbingly, from inside it. This led researchers to revisit the concept of Hawking radiation. Stephen Hawking had theorized that black holes could emit a faint type of radiation due to quantum effects near the event horizon. But what Voyager recorded was nothing like that. It was not faint, not random, and not continuous. It was sudden, powerful, precise and inexplicably directed. A terrifying possibility began to take shape. If the signal was structured and, if it was truly information, then it had to be sent. That idea alone shifted the global research effort from curiosity to quiet panic. If something within or beyond a black hole was transmitting data in our direction, that meant there was intent. That meant something existed in a region where physics tells us nothing should. And more than that, it meant that they, whoever or whatever they were, knew we were here, or at the very least, knew someone could hear them. The notion of using a black hole as a communication medium may sound absurd, but modern physics has already revealed the bizarre behaviors of black holes, time dilation, particle entanglement, across the horizon, and the potential for wormholes connecting distant parts of the universe. If an advanced civilization had access to such phenomena, it's conceivable that they could modulate, encode, and transmit information using the structure of spacetime itself. A system like that would be nearly unfathomable. It would require mastery over gravity, quantum fields, and dimensional interfaces. Perhaps the signal Voyager intercepted was not natural at all. Perhaps it was a relic, a beacon, or an automated system placed in the universe eons ago, waiting for the right observer or the right moment to activate. By chance, or by design, Voyager was in the right place. The tiny spacecraft became something more than an explorer. It became a witness, an antenna pressed to the void, hearing whispers from something far beyond comprehension. The scientific world was forced to confront ideas once left to the realm of speculative fiction, that intelligence may exist in forms and places previously thought impossible, and that the universe may be older, stranger, and more deliberate than we've ever imagined. As word spread, political implications followed. Governments were briefed. International space agencies formed coalitions and task forces, not because there was an immediate danger, but because humanity has always feared the unknown. If information could escape a black hole, then what else could? If intelligence could survive the collapse of matter, gravity, and time, could it manipulate them as well? Could it watch us, the same way we study microbes, with curiosity, neutrality, or intently back on Earth? Telescopes turned toward the black hole in question. Deep space observatories recalibrated to monitor the anomaly continuously. The signal persisted. It pulsed. It shifted slightly in frequency. It modulated in a way that almost seemed to respond. It adapted, matching our observation techniques, hinting that it was aware of our attempts to interpret it. That realization frightened scientists more than anything else. If the signal could react, it was not just structured, it was responsive, and all the while, Voyager continued its lonely journey through space, its instruments still functioning, still transmitting, still listening. Its decaying power supply suddenly became a critical asset. Its weak radio transmitter became a thread connecting us to something beyond the stars. For the first time in decades, NASA debated sending a new mission, a relay probe, something to extend the communication link, something to keep listening. Because if we missed what came next, we might never get another chance. The philosophical implications were staggering. If black holes can release structured information, if they can transmit signals across the cosmos, then what does that mean for entropy, for death, for the limits of thought and perception? Suddenly, the universe no longer seemed indifferent. It seemed layered with design, with purpose. It forced humanity to rethink its place, not just in a galaxy or a solar system, but within a cosmic framework far beyond our comprehension. Let us know your thoughts on this mystery. Leave a comment, and if you're intrigued by what lies at the edge of known science, consider subscribing for more. We've only just begun to listen.